Alright guys, so in the last video we demonstrated how we can uh, take a look at the linear regression line and the linear regression equation for this nonlinear system that we have here. For this video I want to demonstrate how we can look at now the linear model, alright, and compare that to the uh, nonlinear model as well. Alright, so on the graphing calculator we need to go back into the stat screen. So you come find the stat key, click on the stat key. Alright. And then we want to go back into the edit window. So I'm going to get back into the edit window, press enter or 1. Alright. And this time I want to come over here to the L3 column. Alright. And so remember we plotted the time on the L1, we plotted the concentration in L2. And so now I want to come over here to L3, but instead of entering in single values, what I'm going to do is go up here to the top where the, I guess you would call this the column heading is. Alright, so highlighting on the L3. And what I'm going to do here is put an equation in. Alright, and so down here in the input you can see L3 equals. Alright, and I want L3 to be the natural log of the values in L2. Because remember over here to get our linear equation, we did a transformation here of this nonlinear system. And when we did the transformation of the nonlinear system, we took the natural log of the concentration of A. All right, and so I want to create a data set that is the natural log of the concentration of A, which is in L3. All right, and so I'm going to come down here. I'm going to click the natural log button, LN. All right, and so natural log. All right, so L3 is going to equal the natural log of all these values, so of column L2. All right, to do that I hit the second key, all right, and then come down here and locate the L2 button, or L2, yeah, which is on the 2 button. All right, so click 2, and now I see that I'm now going to assign L3 to be equal to the natural log of L2. Alright, so if I hit enter, voila. Now we see that that the graphing calculator has now done that calculation for us, where L3 is now the natural log of each one of these data points in L2. Alright, so that's handy. Alright, and now I want to go and get my linear regression equation. Alright, so I'm going to come back to the stat button, hit stat. I'm going to go over to calculate screen, so hit the over key to get the calculate screen. And I'm going to calculate this linear regression equation again, so I'm going to hit the 4 key. Except this time, now L1 is still going to be my X list because I didn't change the time at all. We're keeping that the same. But for my Y list, that now needs to be the L3 column, all right, which is my linear or my natural log of the concentration. So I need to come down, all right, to the Y list and then do the same thing. Hit second, all right, and now assign L3, which is the 3 key. So I push the 3 key. And so now L3 will be my Y list. I'm going to scroll down to the store regression equation. All right, I'm going to store this equation again in the variables key. So I find the vars menu, vars key, press vars. I want to store this in the Y vars. So I scroll over to the right and then into the function window. And I'm going to store this in the Y1 function. So I push enter there. So now I see I have Y1 is where I'm going to store my regression equation. I can scroll down to calculate and push the calculate key. So here we have our new linear regression equation, all right, which if we look over here to compare to what we did in Excel, all right, very similar. Negative 0.72 is my slope. All right, my y-intercept is 3.52 as well. And I now see an r squared variability, an r squared value of 0.93. So we've done a lot better. We've improved this model. And a correlation coefficient of a negative 0.96. All right. And so if we want to plot this, take a look at this data. All right, I can do the same thing. as before. I'll hit the second key. I want to come up to the stat plot window, so I hit the y equals key. Alright, and I'm going to go into this plot 1 again, and so I hit enter. And the same thing as we did before with the equation, I want to change this y list to the L3 instead of having it L2. So I scroll down to the y list. Alright, I hit the second key and then the L3. Alright, so I want this to be L3, which is the number 3 key. You now see X list is still going to be L1, Y list will now be L3. Alright, so now I can come over here and hit the graph. And I can see now I get a graph, but now my screen is a little skewed. It's zoomed out still. And so I want to zoom back into this. I can come over here and find the zoom key, hit the zoom button. And then it's going to be 9 for that stat zoom. And now I can see that I now get the data points of the natural log of the concentration on the y and the time on the x-axis here, and these are each my data points with my linear regression line plotted here, which I can see. So very nice features in the TI84. The other cool part about having this as a linear regression equation is that if I need to find these values, which you will have to do in your homework and on the exam, I want to find these actual values, I can use this linear regression or this linear form of this model, to find these values. So if I want to find k, k is simply equal to the slope, of this linear regression line. So k is equal to negative 0.72. And if I wanted to find my other unknown, which is the original concentration, and so the original concentration, is going to be equal to, the actual exponential of B, because ln, the original concentration of A, is equal to B, and so all I want to do is take the exponent, of both sides of this equation, to get the concentration A is equal to the exponential of B, and so if I want to find that, then I simply need to, let's get out of this guy, I just simply need to find hit the second button, come down to the natural log button, press that, e raised to the power of my y-intercept, which happened to be 3.52, and so if I enter that in, 3.52, let's go ahead and do 39 for the heck of it, and push enter. So now I can see that my original starting concentration should be 33.9. And of course that's going to be in moles per liter. The K-intercept should be moles per liter per time, or per second, I guess it is. Any questions, send me an email or get in touch with me. And yeah, hope you enjoyed this video. Thanks, guys.